Life as we don't know it, could it be hiding on Venus? For decades, our gaze has been fixed on Mars, searching for signs of past or present life. But what if we've been looking in the wrong place? What if right next door, shrouded in a thick, toxic atmosphere, Venus harbors secrets even more profound? Recent discoveries have thrust Venus into the spotlight, suggesting that our planetary neighbor might not be the sterile, hellish world we once thought. The evidence? Two intriguing chemicals, phosphine and ammonia. These molecules detected in the Venusian atmosphere have sparked a scientific firestorm. Could they be the telltale signs of life as we don't know it? The possibility, however remote, is too tantalizing to ignore. Venus, once dismissed as a scorching inferno, now beckons us to reconsider its potential. Chemical clues, phosphine and ammonia detected in Venus's atmosphere. Our telescopes have become powerful tools, capable of sniffing out the chemical makeup of distant worlds. And when astronomers trained their instruments on Venus, they found something astonishing. In the planet's thick, swirling atmosphere, they detected the faint but unmistakable signatures of phosphine and ammonia. These are not your everyday molecules. On Earth, phosphine is primarily associated with biological processes released by microorganisms thriving in oxygen-starved environments. Ammonia, while having non-biological sources, can also be a byproduct of life. Finding them on Venus, a planet long thought inhospitable, was like stumbling upon an oasis in a desert. The discovery sent shockwaves through the scientific community. Could these chemicals be hints of a Venusian biosphere, perhaps clinging to life in the planet's more temperate upper atmosphere? The possibility was both thrilling and daunting, demanding further investigation and careful consideration of all possible explanations. The recipe for life. Why these gases have scientists buzzing? Why all the excitement over a couple of molecules? Because phosphine and ammonia, particularly when found together, are considered potential biosignatures, chemical fingerprints that could indicate the presence of life. Here's why. Phosphine in particular is difficult to produce through any known geological or atmospheric processes on a rocky planet like Venus. On Earth, it's primarily generated by anaerobic microorganisms, those that thrive without oxygen. Finding it on Venus suggests a process we don't yet understand, and biological activity is a tantalizing possibility. Ammonia, while having potential non-biological sources, further complicates the picture. Its presence alongside phosphine makes the case for a biological origin even more intriguing. Could these two chemicals be part of a complex chemical cycle fueled by microscopic life forms floating in Venus's clouds? The discovery of these molecules doesn't definitively prove the existence of life on Venus. However, it presents us with a compelling mystery that demands our attention. These chemical clues hint at the possibility of life as we don't know it, challenging our assumptions about the limits of life in the universe. Venus, a planet of extremes. Can life truly survive there? Venus has long held the reputation of being Earth's inhospitable twin. While similar in size and composition to our planet, its surface is a scorching hellscape. Temperatures soar to over 900 degrees Fahrenheit, or 475 degrees Celsius, hot enough to melt lead. The atmosphere is a crushing 90 times denser than Earth's, composed primarily of carbon dioxide and laced with sulfuric acid clouds. These extreme conditions make it highly unlikely that life, as we know it, could exist on Venus's surface. However, the discovery of phosphine and ammonia in the planet's upper atmosphere has opened up new possibilities. Could life exist in this more temperate region, floating above the furnace-like surface? The upper atmosphere, while still harsh, offers slightly more forgiving conditions. Temperatures and pressures are lower, and while sulfuric acid clouds pose a challenge, some scientists speculate that microbial life could have evolved to tolerate or even utilize these acidic droplets. The discovery of potential biosignatures in Venus's atmosphere forces us to confront our assumptions about habitable zones and the limits of life. Perhaps, hidden within Venus's seemingly inhospitable clouds, lies a biosphere unlike anything we've ever imagined. The discovery of phosphine and ammonia in Venus's atmosphere was a triumph of observational astronomy. Powerful telescopes, acting as remote sensing tools, allowed scientists to analyze the chemical composition of a planet millions of miles away.
Two telescopes, in particular, played crucial roles in this groundbreaking discovery. The James Clerk Maxwell Telescope, or JCMT, and the Atacama Large Millimeter Submillimeter Array, known as ALMA. The JCMT, perched atop Mauna Kea in Hawaii, was the first to detect the faint signature of phosphine in Venus's atmosphere. This telescope operates in the submillimeter wavelength range, which allows it to study the chemical fingerprints of molecules in planetary atmospheres. The initial detection, while intriguing, needed further confirmation.
Enter ALMA, located in the high Atacama Desert of Chile. This array of 66 radio telescopes working in unison provides unparalleled sensitivity and resolution. Follow-up observations with ALMA confirmed the presence of phosphine and also detected ammonia in Venus's atmosphere, strengthening the case for a potential biosignature. These telescopic detectives, with their ability to scrutinize the atmospheres of distant worlds, are invaluable tools in the search for extraterrestrial life. The discovery of phosphine and ammonia on Venus highlights the incredible power of remote sensing and the exciting discoveries that await us as we continue to explore the cosmos. The initial announcement of phosphine in Venus's atmosphere was met with both excitement and skepticism. Extraordinary claims, after all, require extraordinary evidence.
Some scientists question the data analysis, suggesting that the signal attributed to phosphine could be a false positive or an artifact of the telescope's instruments. However, the scientific process thrives on scrutiny and independent verification. The research team that made the initial discovery welcomed the skepticism, recognizing the importance of rigorous analysis and confirmation. They made their data publicly available, inviting other scientists to scrutinize their findings.
Subsequent studies using independent data analysis techniques and even additional observations from other telescopes have largely supported the initial findings. While the debate continues regarding the exact concentration and distribution of phosphine in Venus's atmosphere, the evidence for its presence is becoming increasingly difficult to dismiss. The controversy surrounding the phosphine detection underscores the self-correcting nature of science. Initial findings are subjected to intense scrutiny, data is reanalyzed, and independent observations are conducted. Through this process, our understanding of the universe is refined and strengthened. The potential for life in Venus's atmosphere has ignited a flurry of research activity. Scientists around the world are now racing to understand the implications of the phosphine and ammonia discoveries and explore the possibility of Venusian life in greater detail.
One avenue of research focuses on laboratory experiments designed to simulate the conditions in Venus's atmosphere. By recreating the extreme temperatures, pressures, and chemical composition of the Venusian clouds, scientists aim to determine if terrestrial microorganisms could survive in such an environment. These experiments are crucial for understanding the limits of life as we know it, and exploring the potential for life as we don't yet know it. If terrestrial life forms, or even their modified counterparts, can thrive in simulated Venusian conditions, it strengthens the case for life existing on the planet itself. Laboratory simulations also allow scientists to test different hypotheses for the origin of phosphine and ammonia in Venus's atmosphere. By recreating potential biological and non-biological processes, they can determine which scenarios are most plausible and guide future observations.
The discovery of potential biosignatures in Venus's atmosphere has fundamentally shifted our perspective on this enigmatic planet. No longer viewed solely as Earth's inhospitable twin, Venus is now a prime target in the search for life beyond our planet.
The coming years promise a renewed focus on Venus exploration, with missions designed to unravel the mysteries of its atmosphere and search for definitive evidence of life. Future missions to Venus will likely involve a combination of orbiters, atmospheric probes, and even potentially landers designed to withstand the planet's extreme surface conditions. These missions will be equipped with sophisticated instruments capable of analyzing the chemical composition of the atmosphere in greater detail, searching for additional biosignatures and even attempting to directly detect microbial life.
The exploration of Venus is not without its challenges. The planet's extreme temperatures and pressures push the limits of spacecraft design, and the thick, toxic atmosphere makes communication and data transmission difficult. However, the scientific rewards of unlocking the secrets of Venus's atmosphere and potentially discovering extraterrestrial life make these challenges well worth overcoming. The journey to Venus is a journey into the unknown, a quest to understand the limits of life and our place in the cosmos. As we venture further into the 21st century, Venus beckons, promising to rewrite our understanding of life in the universe, and perhaps even reveal that we are not alone